Good morning everyone, my name is Alfredo
And I'm Jacklyn, Hermione.
We are from Southern High School and today we're going to present our research regarding the potency of Indonesian biodiversity in medicinal plants as CHK1 inhibitory agents for cancer treatment with bioinformatics and computational chemistry. So what inspires us to make this research in the first place? First, according to the World Health Organization, cancer is the leading cause of death worldwide, with nearly 10 million people died in 2020 due to cancer, or in 1:6 ratio. Second, we also realized that Indonesia is one of the largest countries regarding to the biodiversity, with 14 to 28% of extract of plants are used for medicine. And lastly, we also realized that the time taken to create a drug and the cost would be a lot of money, from 10 to 15 years and 500 to 800 million US dollar. Therefore, to start off the research, we are using a new method of computer-aided drug design through in silico method. Now, there are several steps in the methodology. However, we start from data collecting with PubChem and protein data bank. Then we continue with molecular docking through a software called Autodock Tools. Moreover, we're continuing with the molecular visualization through PyMol and Discovery Studio visualization. After we have processed all the data, we are going to the next process of molecular dynamics using GROMACS in supercomputer. After all the data are obtained, we're going to process through Lipinski rule of 5 and pre-admit using PKCSM to further prove the data.
So from the methodology, we proceed to the docking result of the reference ligand. So in order to be considered as a valid data, it has to be lower than 2 angstrom for the RMSD value, and in this case we got 0.84. And then the Gibbs free energy value, it has to be negative in order to be considered as a valid data. And here we got negative 6.48. And then we also have a control variable, which are the dimension and the coordinate of the grid box. So these are the place where the ligand interact with active site receptor. And then after the reference ligand, we continue to dock the candidate compound. So these are the table of free energy binding results. And from here we got 3 best compound results, which are laurifolin, quercetin, and stigmasterol. So from here we can conclude that they have a more negative value of the Gibbs free energy from the reference ligand. So from the best compound, we then proceed to use the Discovery Visualization Studio. So here we visualize in 2D the reference ligand, stigmasterol, quercetin, and laurifolin. We also figure out the hydrogen bonds between the compound and the receptor. So here we can see that the stigmasterol has no hydrogen bonds, which means that the bond between the compound and receptor is not that strong.
Now, I'm going to discuss the molecular dynamics result. There are 3 key graphs that we're going to discuss, which is the RMSD of ligand, RMSD of receptor, and the RMSF. Now, we have 3 types of color, from orange, which means quercetin, gray, which means laurifolin, and blue, which means stigmasterol. From the RMSD of ligand, we can see that quercetin is the lowest and the most stable compared to the other compounds. From the RMSD of receptor, the quercetin further proves where it locates above 5 angstrom and the highest compared to others. And lastly, in the RMSF, we can see that quercetin is the lowest in the N terminal, but the highest in the C terminal. Hence, from all of the data that we have received, we can further prove that quercetin is the most stable and can bind the longest compared to other compounds. From the visualization, we can also see that quercetin still binds in the last position compared to stigmasterol and laurifolin that has already separated from the protein itself. From hundreds of medicinal plants that is found in the biodiversity of Indonesia, we choose 3 as the representative. First is ranting leaves or bobosat that could be found in Java and Maluku, Marenga or color leaves that could be found in East Nusa Tenggara, and Cemara Sumatra that could be found in West Sumatra. Now, all of these plants is used in the leaves part and contains of metabolic secondary like flavonoid, alkaloid, phenolate, phenolic, triterpenoid, and even tannin. Now I'm going to discuss the Lipinski rule of 5 tests. There are 5 parameters that is tested, which is the molecular mass that must be below than 500 Dalton, and H donor that must be below than 5, H acceptor below than 10, log P below than 5. And from all of this, it will be analyzed from the total violation. Now, the reference ligand as the competitor from other compounds has 0 violation. Meanwhile, comparison to quercetin, laurefolin, and stigmasterol, only stigmasterol that violates 1 parameter in the log P, which is above than 7. This means that quercetin, laurefolin, and reference ligand is safe to be used.
After the Lipinski rule of 5, we also test the compounds with the ADMET test. So these are absorption, distribution, metabolism, excretion, and toxicity. So here we can see that the laurefolin and stigmasterol has a negative value of this max tolerated dose. What this means is that only reference ligand and quercetin is safe to be used and consumed. So this means that laurefolin and stigmasterol, they have a side effect, while the reference ligand and quercetin, it has no minimum to no effect at all. And then also there are the skin permeability. So both the 3 of them, laurefolin, stigmasterol, and quercetin, they failed the skin permeability test. This means that they are not able to absorb well. So for the conclusion, we conclude that from this research that the biodiversity of Indonesian medicinal plants is rich with compounds that have a potential to become a CHK1 inhibitor. This means that it also has the potential to be the cancer treatment in the future. And for the future work, we hope that this research can be continued with in vitro and in vivo.
Thank you for listening to our presentation.